So now that I have permutations in the mix, I'm just going to go back and look at these questions right here. And I'm just going to do it in both ways. This is just to get you a bit more familiar with permutations sometimes. So using only these tiles, determine the number of four-letter arrangements if the letter has an arrangement in any position. So you see I have 1, 2, 3, 4, 5, 6, 7 possibilities right there. And if we're looking for four-letter arrangements, that means I'm going to go 1, 2, 3, 4, or that's going to be 7 times 6 times 5 times 4, which would end up equaling 840. But if I wanted to do this in terms of my permutations, which I've just introduced, this could also be seen as 7p4, which again would equal that 840. Now the next one is if it begins with PR. So I'm going to assume we're saying it begins with PR in that order. So again, what I'm going to get here is I'm going to get my four lines. 1, 2, 3, 4. Since it begins with the P and the R, I only have one possibility for the first and one possibility for the second. And then from there, if I've struck off the two letters, I have 1, 2, 3, 4, 5 left. So this would give me 5 times 4, which would equal 20. Or subsequently, I could look at this as 1 multiplied by 5p2. Now again, you completely have your choice on this one. For my next one, and here we want to have two vowels in the middle. So I have 2 vowels in total. Now in this case, this is going to actually fall into a fundamental counting principle a lot more easily than a permutation, so I'm just going to do the fundamental counting principle way of this. So I have 1, 2, 3, 4. Now I have 2 vowels in the middle, so since we only have 2 vowels, that means I could place 2 right there and 1 right there. Then I have another letter on either side. Had I had 3 vowels, I could just place the vowels right back in here. But I have 5 and I have 4, so it'd be 5 times 2 times 1 times 4, which would end up giving me 40. The last one, we want to know with 2 consonants in the middle. So I go 1, 2, 3, 4. Now here, we're going to have a consonant and a consonant. So in total, I have 5 consonants, and then I have 4 consonants. From here, there's no restriction on my 2 other letters. So that means that I have 5 letters and that I have 4 letters after I've placed those 2. So I get 5 times 5 times 4 times 4, and that will give me 400. Find the number of permutations, again we see that word, of the letters of the word kitchen if there are no restrictions. So I have 1, 2, 3, 4, 5, 6, 7. So I have 7 letters. I could look at this as being 7 factorial, or we could draw out the 1, 2, 3, 4, 5, 6, 7 lines and go 7 times 6 times 5 times 4 times 3 is 2 times 1, or we could say that that is equal to 7p7. So I punch in 7 factorial, and that gives me 5,040 ways. The letters K, C, and N must be together, but not necessarily in that order. So I call these package questions. And how my package question works is if you imagine that K, C, and N, and I'm going to draw like a little bag. Isn't that a sweet bag? And in that bag, I have my K, C, and I have my N. So this is my package. Now, from here, in my package, I'm going to treat this as 1. If I take out the K, the C, and the N, you'll notice we have 1, 2, 3, 4 letters left. So now I have 4 letters plus my package. So that would give me 5 factorial, or 5p, 5 ways of ordering the 4 letters plus the package. But then I have the arrangements in the package. So my arrangements in the package would end up being, well, 3 letters, so 3 factorial, subsequently 3p3. And then we multiply these, so I end up getting 5 factorial multiplied by 3 factorial, or subsequently 5p5 multiplied by 3p3, and doing that, that ends up equaling 720 ways. So these are what we call our package questions, and when we say they must be together, that's the package. If it had to be together in that order, we would just end up changing that 3 factorial to a 1, because there'd be no orderings of those letters. Now, the letters K, C, and N must not be together. And these are or never together problems. So for the way that we're going to do this, again, in Kitchen, I have 1, 2, 3, 4 letters that are not K, C, and N. So I go 1, 2, 3, 4 letters that are not K, C, and N. And if I place those, we get 4 times 3 times 2 times 1. Now, my K, C, and N, what I can do is I can place in any of those 5 spots. Because I don't want them to be together, we always have to have that separation in between. So that leaves me 5 spots upon which I can place the K, C, and the N. So the answer for this is going to be 4 factorial, and then we have to figure out, well, how can we place these spots? Now, the way that I'm going to explain this isn't completely correct, but it works 100% of the time, and it's a lot easier than the actual explanation. So I'm just going to say we have 5 spots, and we're placing 3 letters. So I'm going to say that's equal to 5p3. So this will give me 4 factorial multiplied by 5 math p3, and this will give me 1,440 different ways that we can make this work. Anne, Brian, Colin, Diane, and Eric want to go watch a movie and sit in 5 adjacent seats. How many ways can this be done if? Okay, well, Brian has to sit next to Diane. So that again becomes a package question. I have Brian and I have Diane. From there, we have 3 people left, so that would give me 3 factorial. Whoops, my bad. So that would give me 3 people plus the package, so that would be 4 factorial. But then I have the 2 people in the package, so that would give me 4 factorial multiplied by 2 factorial, which would give me 48 ways. Anne refuses to sit next to Eric. So again, this is never together. There's a song in there somewhere. So Anne refuses to sit next to Eric. That means I have 1, 2, 3 people, and that would be 3 times 2 times 1. I don't know why I wrote that on the bottom. And then from here, I have 1, 2, 3, 4 spaces. So my 3 times 2 times 1 would give me 3 factorial, and then I have 4 spaces, and I'm placing 2 people in there. So this would be 3 factorial multiplied by 4p2, which would give me 72 different ways. Boys sit together and girls sit together. So what do we have here? We're going to assume that Brian's a boy, Colin's a boy, and Eric's a boy, and that Anne's a girl and Diane's a girl. So I have 3 boys and I have 2 girls. So I can look at this as being a double package question. So I have 2 packages and nobody else, which would give me 2 factorial. But then I'd multiply by the 3 factorial because that's the number of ways I can arrange the 3 boys, and I'd multiply that by 2 factorial because that's the way that I can arrange the 2 girls. So the 2 packages is either going to be boys first, girls second, or girls first, boys second, and then I have the 3 factorial ways I can arrange the boys and the 2 factorial ways that I can arrange the girls. And this would give me 24 ways. Now, this will actually take us back to permutations and the examples that I'm about to go through.